everyone. Thought I'd come outside. It is such a pretty day today. Might be a little windy though, so I hope you can hear me. So if you're watching this, you should have already watched the Bill Nye video that was talking about something called seafloor spreading. And it talked about a scientist named Harry Hess. Okay, now here's a little trick I always tell my students to remember, because we've talked about a lot of scientists. We have Alfred Wegener, we've talked about, you watched a video about Marie Tharp. So for Harry Hess, his big idea was seafloor spreading. And so his last name, H-E-S-S, the two S's in there can help you remember seafloor spreading was his big idea, okay? So if we were in class like normal, we would be using these seafloor spreading models, and it's just a cardboard box that has some strips of paper in it. But what I wanted to show you is how it works to kind of help explain the idea that the seafloor is spreading at these mid-ocean ridges. So on this box, I've got the top of it right here. This top of the box labeled ocean floor or the sea floor. And then I've got a little slit cut into the box right here, and then this line kind of going on either side of the slit, and that's labeled ridge. I don't know if it's backwards to y'all or not, but it says ocean floor and ridge. And so this would be like a mid-ocean ridge, and this is the ocean floor. So for example, the mid-Atlantic ridge. And so this would be just a tiny little section of that mid-Atlantic ridge. And so these strips of paper, we can pull them out of the box and lay them flat. There's two strips of paper, and lay them flat on the box on the ocean floor, and they're numbered. The first ones that came out were numbered number ones, and then maybe you can see right here, then these little the next like stripes are labeled number twos, and then there's number threes, and then there's number fours. Okay, so one of the things that Harry Hess discovered was he was taking samples. They drilled down and got like rock samples of the rocks around this mid-Atlantic ridge, and they found that the further away the rocks were from this mid-ocean ridge, the older they were. They can figure out how old rocks are. And they figured out that, okay, this distance away from the ridge, these rocks in this area were the same age as the rocks, the same distance from the ridge, but over here on the opposite side, leading him to believe that rocks 1 and 1 were created at the same time, and that the crust here, the surface of the earth, has spread out in opposite directions. Same thing with rocks from the number 2 area were created at the same time. Number 3 created at the same time. Number 4, look, they're pushing up and being created at the same time from that molten magma underneath Earth's crust. And so this happens over like millions and millions of years, very slowly. And then the rocks in the sections 5 would be created at the same time, and over time slowly moving away. So then the question is, well, if Earth just keeps making more and more and more crust, why is Earth's crust not getting thicker and thicker and bigger and bigger? Well, it's not, because there's places on Earth where the crust is actually being destroyed. And that's kind of where we're headed with our next, well, we'll get into that next week, but okay. So new crust is created at mid-ocean ridges, and the crust pulls apart slowly, and rocks are forming and spreading apart from each other. Now, where the crust is destroyed is a thing called a trench. So crust is destroyed at a trench. It gets recycled down back into the mantle of Earth, which we'll talk about later on, okay? So, as for now, we're going to cut this off, and we'll see y'all next time.